All right, working with L'Hopital's rule is really an easy rule to use, and it allows us to check out limits where we get what's called an indeterminate form. Remember, we're interested in what's going on as we approach a number, not when we're actually at a number. However, we can always substitute in a number to get that approaching value. Life is really nice. In this case, we were looking at the limit as x approaches 125 of the cube root of x minus 5 over x minus 125. Well, when I substitute in my value that I've got for x here for my limit. So if I substitute 125 into here and here, that's the easiest way to find any limit, okay? Because when you're talking about really close, sometimes it's easiest to substitute that value in. The problem is with this particular guy, I wind up with an indeterminate form. I wind up with the cube root of 125 minus 5 over 125 minus 125. Well, the denominator is a straight up 0, and the cube root of 125 is 5, so that's 5 minus 5, and that gets me 0 over 0. This is what's called an indeterminate form. We don't know what's going on because we get this specific thing. 0 divided by 0, can't have that. Infinity divided by infinity, can't have that. That doesn't give us enough information. So what we're going to do is we're going to use L'Hopital's rule, which says take the derivative of the top independently of the bottom. We're going to take derivative of the top, we're going to take derivative of the bottom, and then we're going to reapply our limit rule of 125. Now, if you graph this and look at it, you should see that when we're at 125, we're actually approaching a specific point, and that's always the easiest way to look at a limit. But when we analyze this analytically, we're going to do it a little different. So what I've got is x to the third minus 5. That would be f of x. And so the derivative of that is 1/3 x to the negative 2/3. The derivative of the 5 is 0. So f prime becomes 1 over 3 x to the 2/3 power. Let's look at g. G would be my bottom equation, which is x minus 125. So g prime is equal to 1. All right, g prime is equal to 1. So what do I do now? I put the top function, the f prime, over g prime, and I re-evaluate my limit. All right, so now I'm going to look at the limit as x approaches 125 of 1 over 3 times x to the 2/3 divided by 1. So that whole 1 part doesn't even matter. Now I can substitute in my 125. This becomes 1 over 3 times 125 to the 2/3 power. In other words, the cube root of 125 squared. The cube root of 125 is 5. Squared is 25. So 1 over 3 times 25, which is 1 over 75. And that's the limit that we're approaching with this particular problem using L'Hopital's rule. Okay, we're going to look at this graph now, the limit as x approaches 0 from the left of tangent 3x over x. And when we investigate this, what we're really wanting to do is we're wanting to look at as we come in towards the 0 on the x-axis from the side of the number line, what does our graph approach? And I went ahead and graphed this on my calculator because I'm just not super familiar with this shape, and it looks something like this right here. We're going to go very thin parabola shape, and then it looks like there's some sort of asymptote around here where we look like this from both sides. So and then there's more of them, and the dips get a little bit more pronounced the further you get over the bends. And so here's how this guy looks, and we're really interested in what's going on at 0. That's right here, and it looks like there should be a limit of 3. Okay, but when we check this guy out by substituting 0 in, which is the easiest way to check a limit, what happens is I get the tangent of 3 times 0 divided by 0. Well, the tangent of 0 is 0. This is an indeterminate form. I have to use L'Hopital's rule. To use L'Hopital's rule, we just take the derivative of two separate pieces. We take the derivative of the top, and then we take the derivative of the bottom. All right, separately, independently of each other. There's no quotient rule or anything like that. So I'm going to let f of x equal tangent 3x. And the derivative of that is tangent squared. Sorry, secant squared. 3x, and there's a chain rule here because there's a 3x inside. So 3x times 3. So that would give us 3 secant squared 3x. G of x then would be x, and the derivative of that is just 1. So I don't even need to write this down. That would be our new denominator would be 1. I'm not even going to bother with that. So here's what I've got. I've got the limit as x approaches 0 from the left of secant 3 secant squared 3x. Now remember, secant is 1 over the cosine, okay? 1 over the cosine. So the cosine at 0 is just 1. So what I'm working with here, when I substitute my 0 in, I'm looking at 3 times secant squared of 3 times 0. Well, that's 0, and the cosine of that is 1. The reciprocal of 1 is 1. So I end up with 3 times 1, which is 3. And that's what this limit goes to. And graphically, that's what it looks like it should be.